All right, so we are going to continue with 4.5 section B, or part 2, if you will. And so here we're going to talk about an oil rig, and we're going to pipe oil from the rig, which is at W, and we need it to go 5 kilometers underwater. And then it's got to go along the shoreline at a certain price. And so we want to minimize the cost of laying the pipe. So we need to figure out where point P needs to be, okay? Because we want to minimize the cost. Okay, so in order to find the total cost, we need to read the problem. And it says the closest point A on a straight shoreline is 5 kilometers. And the point P between A and B, and then onto point B from P. So we know that those are a total of 8 kilometers apart, and we know that the distance there is going to be 8 minus x, whatever x is. And so all of this is underwater, and then the part that we have that's going to be under the shoreline, because remember, we're going to pipe it, we're going to pipe from between, excuse me, according to the problem, it says oil is to be piped from W to a shore point B. We need to get oil right here. That's where we're trying to get the oil to, okay? So in order to do that, we need a couple of equations. And the first equation we need is to figure out what this distance right here is going to be, okay? And so we know how long it is going to be underwater. And I'm going to cheat. I'm just going to give you the answer. That's going to be the length of the hypotenuse, or the length underwater. And we also know that it's going to be 8 minus x along the shoreline. And we know how much it is per kilometer. So what we're going to do is set up the first equation for cost, which is going to be $1 million times the distance that it's underwater. And then we're going to add to the cost the amount of money that it's going to cost us per kilometer times the number of kilometers it's going to be under the shore, or over the shore, if you will. Okay, so I'm going to go ahead and pause now. I'm going to take the derivative, set it equal to 0, and then figure out what the total cost is going to be. And then I'll come back. You're pausing now to check your work. Pause now. All right, so there's my cost. I did a simple change in the cost here. I just went, let's just call that one unit, whatever it is. It's millions of dollars, but it's 1 unit. And this is half that. So if it's 5 million, then it's 2.5 million. In this case, it's 1,500,000. Take the derivative, and then you're going to get x has to be 5 divided by root 3. And so to make sure we've answered the question, it said, where should it be located to minimize the cost? It should be 5 divided by root 3 from point A. Okay, let's move to the next example. Find the radius and the height. So my final answer is going to include radius equals and height equals. That's got to be my final answer. Of the right circular cylinder of largest volume, so I'm looking for a Vmax, that can be inscribed in a right circular cone with radius, total radius of 6 and a total height of 10. Okay, and so this is going to be some little h and some little r. Okay, so I will hint to you right now before you pause it. What you're going to want to do is think about the formula for, I'll give it to you. There it is. And now you want to think about similar triangles. Okay, so I'm going to pause now. I want you to pause, and then my work is going to pop up. Pausing now. All right, so here's the work. remember, I was looking for Vmax. I want Vmax, so I start with the volume formula. The nice thing about this problem was they gave us the ratio. Okay, so if you didn't see that, if you could not come up with this proportion or this proportion on your own, we need to work on our algebra similarity stuff because that's going to be huge for this section. Okay, so they gave it to us. So you can pause at any point and take a look at the work. Went all the way down to here. And then I brought that up to here. Okay, so black first, and then I worked through the red right here. Okay, final answers are in the box. I'm going to scroll back up. You can pause this at home, but I'm going to scroll back up. Those are my final answers, and I need to make sure that I include my units. Okay. All right, so pause, take a look at the work, and then we're going to start the next example. Okay. All right, so problems involving intervals that are not finite, that are not both finite and closed, which means this one's going off the end over here. So take a look at the graph. Okay, a closed cylinder is to hold 1 liter of liquid. How should we choose the height and radius to minimize the amount of material needed to manufacture? Okay, so we don't have any bounds. We just want the cost or the amount of material. In this case, we're not concerned about cost, just the amount of material, which I will hint to you is surface area. So take a look at the picture. They gave you a graph. I'm going to actually show you how to come up with that, and then you can take a look at my work. So pause now and try to set this up. Okay. So first things first, they gave you the picture on the side. Again, you will be generating these pictures on your own. The examples in the book actually have the diagrams. So when we're looking at surface area, you want to make sure you have the top and the bottom, and then you have the side. Okay, the side would be the difficult part because you had to remember that this label or edge of the can is actually the length of the circumference of the circle or the perimeter of the circle maxim. And then we have the height. Okay, so we come up with our equation. We need to use the information given. So they gave us the volume. So we can use our volume equation to solve for one of our variables, R or H, and that's your choice. Okay, so here's the work. Scroll through. Pause if you need to. Let me get rid of this. Pause if you need to. And take a look and make sure that every step of the way you have the same thing. The last thing that you need to make sure that you do is include your units. So I hadn't put my units down here. I needed to put them in. Okay, pause if you need more time to look at that. I'm going to head over to the next one, so you can pause now. Okay, find a point on a curve, y equals x squared, that is closest to the point 18, 0. All right, so you're going to need a picture. So let's go ahead and pull up a picture first so we can graph this. And we're going to want to use this. So I'm now going to zoom out. And then we're going to pause, and you're going to attempt to graph this on your own and see what you get. So go ahead and pause now. Okay, so the first thing I had to do was realize that I needed the distance. So that is the sign for distance, closest to. And so I came up with the distance formula. That would be something from geometry. But if not, I could use Pythagorean theorem, because the distance between 2 points is really just the hypotenuse. And so every point on the curve y equals x squared has an ordered pair x comma x squared. Okay, so x comma x squared is what we're looking at. So take a look at the work. Pause at any point. I will stress that down here, I checked my answer. I used some synthetic division to come up with a 0. PQ test right here, if I need to do a PQ test. The other option is to pull out your graphing calculator. Now, if at any point you have to have a calculator, we will not have that question on the first portion of the test. Okay, so you'll be able to do these without a calculator. So if you need to, pause and take a look at the work. Remember, when you come in tomorrow, you should be comparing your work to my work so that when you come in, you have questions. All right, economics. All right, so take a look at this one. I'm going to pause. I'm going to crank out my work, and then we'll come back. All right, so this was actually one of the easier problems, except for the fact that you had to take a look right here. Let's do this. And recognize that you're going to sell it for $200 per unit. So that's this. Okay, that's going to be how much you're going to generate as your return, your revenue. And then you need to offset that with the cost. So we need to put the parentheses here because that whole equation represents the cost. This is all the cost. And so once you distribute that minus sign, take the derivative of your profit. You want to maximize your profit, hopefully. And then we're going to solve for x. So according to this, 20,000 units. Okay, and we're well under our 30,000 in that certain amount of time. So that's going to be your final answer, 20,000 units. Okay, here's your quick check. It's on page 283 in your book. The answers are on page 288. You should also be completing the worksheet from Master Math. Okay, the optimization worksheet. And you should be becoming my students. I'm not sure if Mr. Clinton had your class printed yet, but my students should come into class tomorrow with those first 2 pages done. I'm trying to find mine right now so I can tell you the exact numbers. But the first 2 pages should be done, okay? The first 2 pages. So my students, first 2 pages, okay? Not counting 1 through 4. We did those before. Nice try. You're going to pick up after that. So I want to say numbers 5 through 10 in addition to the quick check. How about that? 5 through 10 in addition to the quick check for my class. All right. Mr. Clinton's class, if you have not printed the optimization worksheet, I believe that's number 19 on the Master Math website. Okay. Coming in tomorrow, my class, make sure you print it. You have it. Mr. Clinton's class, print that and bring that in with you. All right. Good luck.